If p of x equal to ax plus b, find the zeros. Now polynomial here is p of x, which is ax plus b. To find the zeros, I have to equate it to 0. So ax plus b equal to 0. So ax will be minus b. I take the b on the other side, and x will be minus b by a. So the 0 of the polynomial is minus b by a. And here it is done. We have px equal to ax plus b. For the zeros, px should be equal to 0. That means ax plus b equal to 0. X equal to minus b by a. The graph of y equal to px is given below. For some polynomial p of x, find the number of zeros of p of x. To find the number of zeros, we need to know in which places does this graph intersect the x-axis. So here is 1, 2, 3. So it intersects the x-axis at 3 places. Here is the graph. This is the graph of the polynomial, and it intersects the x-axis at 3 places. Hence it has 3 zeros. So the number of zeros of this graph is 3. So there are 3 zeros. The 18th, if one zero of the quadratic is a negative of the other, find the value. So here is our quadratic f of x, which is 4x square minus 8kx minus 9. And if we compare it with the standard, that is ax square plus bx plus c, we see a, which is the coefficient of x square, is 4, b, which is the coefficient of x, is minus 8k, and c, constant term, is minus 9. Now in the next part they have said that one zero is a negative of the other. So when it comes to the 0, if one is alpha, the other one will be minus alpha, because it is a negative of the other. We know sum of zeros equal to minus b by a. Now the zeros are alpha minus alpha equal to minus b by a, minus, we see the b is minus 8k. So minus of minus 8k over 4. So minus alpha will be 0 equal to 8k over 4. So 0 into 4 equal to 8k, and we have k equal to 0 over 8, k equal to 0. So here's the solution. The two zeros are negative of one another. Hence, if one is taken as alpha, other one is taken as minus alpha. So when you compare it with the standard, we find a equal to 4, b equal to minus 8k, c equal to minus 9. We know the sum of the zeros is minus b by a. So you put your values and you get your answer. If x equal to minus 3 is a zero of the polynomial, is x the zero of the polynomial? So the polynomial given to us here, p of x equal to 2x square plus 5x plus 3. Now we have to check, is minus 3 the 0? So for p minus 3, so wherever there is x, I will put minus 3. 5x minus 3 plus 3. So this is 2. Here we have 9. 5 minus 3 plus 3. 18 minus 15 plus 3. So here we have 18 plus 3 is 21 minus 15, which is equal to 6. So we see that the remainder equal to 6, and it is not equal to 0. Therefore we can say that minus 3 is not 0 of the polynomial. So here again we have p of x, this is the polynomial. By remainder theorem we do p of minus 3, We find the value and we find the remainder as 6. Since we have a remainder 6, we can say it is not the 0 of the polynomial. Write a quadratic polynomial whose sum and product is 3 and minus 2. So the sum of the roots, that is alpha plus beta, is 3, and the product of the roots, that is alpha beta, is minus 2. Now we know the polynomial is x square minus sum plus product. Let's put the values. So we have x square minus sum. Sum is 3 and the product is minus 2. So it will be x square minus 3x minus 2 will be your answer. And here again it's written the sum is 3, the product is minus 2, and here is the formula x square minus sum plus product. On substituting we get this value. Find the sum of the zeros of the given quadratic. So we have p of x, the given quadratic is minus 3x square plus kx. Now if you notice, the quadratic has got only 2 terms. So we write it in standard form. To write it in standard form, we write 3x square, 0x, which is missing, plus k. Now when we compare with the standard ax square plus bx plus c, we say a is minus 3, b is 0, c is k. We need to find the sum of the zeros. Sum of zeros equal to minus b by a, and which is now minus, we saw the b is 0, so 0 by a is minus 3, which is 0. So the sum of the zeros, that is alpha plus beta, equal to 0. Here again for the solution, this is the polynomial. You compare it with the standard ax square plus bx plus c. When you do it, you get a equal to minus 3, b 0, c k. Sum of zeros is minus b by a, and putting the values you get alpha plus beta equal to 0. Quadratic polynomial, one of whose zero is 2 plus under root 5, and the sum of the zeros is 4. So here we have one zero, that is alpha is given as 2 plus under root 5. And they said sum of the zeros is 4, which means alpha plus beta equal to 4. Now we know alpha, we need to know beta. Beta is a question mark. So let's find beta. So alpha is 2 plus under root 5. Now beta we do not know, plus beta equal to 4. So beta equal to 4. This 2 plus under root 5, we take it on the other side, becomes minus 2 minus under root 5. So beta equal to 2 minus under root 5. Now we know beta. So we put beta as 2 minus under root 5. Now that we know alpha and beta, we can write the quadratic. Now our formula for quadratic is x square minus alpha plus beta, sum of roots plus product of roots. So x square minus, sum of roots was given to us is 4 here. So we're going to put 4x. Now product of roots is alpha into beta. Alpha is 2 plus under root 5. So we write 2 plus under root 5. Beta is 2 minus under root 5. 2 minus under root 5. So it will be x square minus 4x plus, this is a plus b, a minus b, which is a square minus b square. We put it in bracket, so this is x square minus 4x plus, this is 4 minus 5. And if we solve this, it is x square minus 4x minus 1. So this is our quadratic. Here again they have solved it. So we have 1 0 is 2 plus root 5. The sum of the zeros is 4. Therefore this is the other 0. Here is the other 0. So the product of zeros is minus 1. So the polynomial is x square minus sum of zeros plus product of zeros. Here we have to find the zeros of the quadratic. So the quadratic is given as 6x square minus 3. In the first thing, we take 3 common out. So we have 2x square minus 1. Now to find the zeros, we need to put f of x equal to 0, which is 3, 2x square minus 1 equal to 0. So 2x square minus 1 equal to 0, 2x square equal to plus 1, so x square equal to 1 by 2, x equal to under root of 1 by 2, so plus and minus. So x equal to plus under root 1 by 2 or x equal to minus under root 1 by 2. So here we have 6x square minus 3, we take 3 common out. So to find the zeros, we do fx equal to 0. Next, we have 2x square minus 1 equal to 0, x square equal to 1 by 2, so x equal to under root of 1 by 2, which is under root 1 by 2 minus, so this is your answer. The sum and product of the quadratic are 0 and under root 15. Find the quadratic. So sum with alpha plus beta is 0 and the product is under root. So under product alpha beta is under root 15. We have to find the quadratic. So we know the quadratic is x square minus sum plus product. So which is x square minus sum is 0x plus under root 15. So x square plus under root 15 will be your quadratic. So here again the sum is given as 0, then product is under root 15. So we have x square minus sum plus product. So the answer is x square plus under root 15. Find a quadratic whose one zero is minus 8 and the sum of the zeros is 0. So 1 0 is minus 8, means alpha is minus 8. And the sum of the zeros is 0, which means alpha plus beta is 0. Now we need to find the beta. We know alpha is minus 8, so we put minus 8 plus beta equals 0. So beta will be 0 plus 8. So beta equal to 8. So beta is 8. Now if we know alpha plus beta and beta, we can find the quadratic. It will be x square minus alpha plus beta x plus alpha beta, which means x square minus alpha plus beta x plus alpha beta minus 8, beta is 8. So x square, this is 0 minus 64. So your answer here is x square minus 64. So the same thing is printed out here. So if 1 0 is given as minus 8, which we take as alpha. The sum of 0 is 0, that means alpha plus beta, this alpha plus beta is 0. So when you do alpha plus beta is 0, we know alpha is minus 8 plus beta 0, so beta will be 8. So here is a polynomial x square minus sum plus product. So you get x square minus 64. Find the value of k such that the quadratic has the sum of the zeros half the product. So here our quadratic is f of x, we can call it p of x. So minus k plus 6 x plus 2, 2k plus 1. Now when we compare it with the standard ax square plus bx plus c, we see that the a equal to 1, b equal to minus k plus 6 and the c equal to 2, 2k plus 1. Now the condition given to us here is that the sum is half the product. So let us write that. Sum of the zeros is half the product of the zeros. Now sum of the zeros is minus b by a. Product of the zeros is c by a. Now let's put the values. So we have b is equal to here minus k by 6. So we have minus of minus k by 6. A is 1. Half of c, this is c. So it is 2k plus 1 over 1. So this cancels out. So we get minus of minus is plus. So k plus 6 equal to 2k plus 1. Take the 2k on this side. 1 minus 6 minus k minus 5. K equal to 5. So this is the answer. K equal to 5. And this is exactly what they have done. Sum of the zeros is half the product. So this is sum of the zeros and half the product, and then you solve it. You then carry on solving it and you get k equal to 5. Next, divide the polynomial by 2x plus 1. Write the coefficient and remainder. So this is quite a direct sum. So we have our coefficient 2x plus 1, remainder 4. If 1 is one of the zeros of the polynomial, find the value of k. So a polynomial p of x equal to x square minus x plus k. Now 1 is a 0, therefore we do p of 1. So wherever there is x, we put 1. If it is a 0, then p of 1 is equal to 0, which means 0 equal to 1 minus 1 plus k. 0 equal to 0 plus k. K equal to 0. Find a quadratic polynomial whose sum of zeros is 3. Sum of zeros means alpha plus beta equal to 3. And the product of zeros is 2. Alpha into beta equal to 2. So we directly go ahead and find. We have x square minus alpha plus beta x plus alpha beta. So x square minus alpha plus beta is 3. So here we have 3x. Alpha beta is 2 plus 2. So quadratic is x square minus 3x plus 2. And that's exactly what is done here. We have alpha plus beta is given as 3, alpha beta is given as 2. Then we have x square minus alpha plus beta x plus alpha beta. Here we've got to find the number of zeros for this polynomial. So to find the number of zeros, we find how many times has it cut the x-axis. So here is 1 point, here 2 times. So the number of zeros will be 2, as it cuts the x-axis at 2 different points.